Welcome back everyone to another episode of the Doom series. Alright, so we'll begin by looking at what we'll be making today, and as you can see I am inside of my scene, and you can see that as I move around, the height of the character automatically adjusts to move to the correct position according to the the actual values of this, so the value of the sector's floor. So you can see we can climb stairs this way, and we can like climb onto ledges this way. You can see here I can get a view from high up, and here climb onto windows. We can jump into these pools, we can go down these stairs, go up these stairs again, and the height is automatically adjusting. And this actual height adjusting is fairly simple to implement. It's actually very simple and like it's trivial, but the problem is that we can take the sector's floor to figure out the correct height of the camera. However, the actual problem lies in the fact that we do not know the current sector that the player is in. So we need to figure out a way to make sure that we always know what the sector the player is in. Now for this we are going to use the BSP tree. So we are going to traverse the BSP tree, and we are going to use the BSP tree, or the binary space partitioning in the Doom, and we can use that to figure out where we need to go. And for this we can load the data from the original WAT file. However, we are also generating GL nodes, which also generates a GL BSP tree, so we can just use a BSP tree in that, since we have already got GL segments and everything. So we are going to do that. So I'm going to go ahead and first of all begin by opening up map.h. As you can see in here we have got the basic stuff here, and the only thing that has changed is that we have got a new type here called GL node. Now this consists of two unsigned 16-bit integers, which are indices or IDs of the front and back child of this node. So as you know, this is a binary space partitioning, which means that the 3D, or actually 2D in this case, the 2D space is divided into in different nodes. Each node contains of like two basic childs, so each node has two childs. That's why it's called a binary space partitioning. And apart from that, it also has a two other pieces of data, two vector 2s. One is the partition of this node, which represents the partition line, and the other is the delta partition, which represents the distance from this partition to the next, or that. So this partition to the end, it represents that. So it is the delta of the partition, while this is the actual partition. Now in GL math we have got we actually don't need this, so we have got like a new size t here, which is the number of nodes, and we have also got a list of pointer to like an array of nodes. So now let's go ahead and open up the wat.c file, which consists of the second major change, which is that I'm gonna just remove this here, and you can see we have got this function here called read GL nodes. Now this function is being called inside of here. So in here we are calling the read GL nodes functions, and it's defined up here. It's just like any other read GL function. And for the read GL nodes function, what we do is we take a pointer to a GL map and a lump and everything, and each node is 28 bytes in size, and we allocate the memory for the nodes and set the number of nodes, and then we loop over the nodes, and for the partition x and y and the delta partition x and y, we read the data as offsets 0 through 6, while for the front and child ID we do at offset 24 and 26. Now between them are the bounding boxes, which we don't really need, so we won't read them right now. So yeah, that's pretty much it for the basic stuff. Now let's go ahead and open up first of all we'll open up vector.h, because in here we have added some functions for the addition and subtraction of two vector 2s, because we are going to be needing those. So just a couple of utility functions. As you can see, we have got these here. So that's pretty basic stuff. So I'm going to open up engine.c, and in here you can see we have got a function prototype for a new function, which is called map get sector. Now what this does is that it is essentially a function that takes a pointer to a map and a pointer to a GL map, and then it has got a vector 2, which is actual position, and then it returns the sector that position is located in. So that's some basic stuff. And apart from that, we have got three other values here. One is a static float called the player height, and these are an actual map and GL map here, which we have stored as global variables instead of local ones, because now we need the map even after the init function. We need it inside of the other functions as well. And we have also got the player height here, so that's all pretty awesome. So what we do is that inside of engine initialization, we don't actually create those things here. And another important thing is that we don't actually call the free functions on the map and GL map. So we don't use local variables, we use the global ones, and we don't actually delete those variables. So if the thing is player start, then we actually set the player height to the info height so that we can access this later when we want to change the player's height. So for that we will need to keep this in a variable instead of hard coding. This will be a much better way. So that's all pretty basic stuff. Now in here you can see we are using the map get sector function. So first of all we calculate the vector to position, and since we negate the y-axis when we are generating our map, we need to make sure we use negative cameras or c position for the y-axis of this, and here we just use camera position x, and that gives us the actual 2D position according to the do map. And then we use map get sector with this position and the map and GL map that we have got, and if that sector is not null, which means it's valid, then we are going to just set the camera's y position to the sector's floor value plus the height of the player. And yeah, that's pretty much all we need to do. And another thing we'll need to change here is that we'll need to look at the actual map. So we're going to go ahead and say I'm going to just change this here. I'll explain this in a second. So we're going to say num nodes -1. So this function basically starts by traversing the BSP tree. So first of all we get the ID, which represents the ID of either the node or the subsector depending on the context. We'll learn more about this later. So this ID is basically like a 16-bit integer, and the topmost bit, which is bit 15, that represents whether this ID represents a node or a subsector. So if the child ID of a particular node is like equal to has got its 15th bit set, then in that case it means that it is not a ordinary node, but instead it points to a subsector. So we need to make sure that we have got this here like that, and here if the ID is greater than the number of nodes, we return null. Now we start at the last ID, as you can see, because the way it is organized, the last entry in the nodes data is always the one we need. So we have got our whole node structure and everything, and the last entry in that data, which means that the actual last value is the root node, which means where the BSP partitioning starts. So that node is not a child of any node, but it is instead the root node, and it's always located at the end, so we can calculate it like this. And then we go ahead and start the looping process. So while the ID's topmost bit, so the 0x8000 represents the 15th bit, while that bit is not set, which means it's equal to 0, ending it, you can see it sets equal, if it is equal to 0, then in that case it means that we are pointing to a node. So as long as we don't reach a subsector, we are supposed to continue, and we check if the ID is greater than the number of nodes, we return null just to make sure we don't actually read any incorrect data. Then we get the node, then we calculate this delta variable by subtracting the node's partition from our position that we've got, and then we find out whether this node is behind the delta or not. So for this, what we do is we just go ahead and get our deltas x, multiply that by the delta partition y, and subtract from it our delta y multiplied by the delta partition x. And if that value is less than or equal to 0, that means that the position that we are at is behind the node partition. And if that is the case, then we are going to set the ID to the back child ID, or else we are going to set it to the front child ID. So we are going to just keep recursing it that way until we reach a subsector. And once we do this, exit this loop, it means that we have reached a subsector. So we are going to go ahead and add this with 0x7 FFF to extract the lower 15 bits and not the 16th bit. The final bit, we don't accept that. And then we check if it's greater than the number of subsectors. That means something wrong happened, we just return null. It should never happen, but just in case. And then we get the subsector from this, and we need to make sure we to AND it with 0x7 FFF. So we get the subsector like that, and from the GL map, and then we get the GL segment from the GL map as well. The subsector's first segment is used for that. Then we get the line def by getting the map's line def based on the segment, and then we get the side def. Now for getting the actual side def, we check if the segment side is 0. If it is 0, then that means we can get the front side def, else we need to get the back side def. So this is the direction flag. And in the end, we are going to just go ahead and return the sector that is pointed to by this side def. And another thing is that if I open a map.h, earlier on you might not have this side here inside of side def. If you don't, make sure to add it. I'm pretty sure you will have it though. So actually it's in GL map.h. So we have got the side here, but in case you haven't got, then make sure that you actually have that data initialized correctly. And anyways, in the end, we just return the sector that we found using that method. and this is pretty much all we need to do. So with that we can get the correct sector and we can use it to get the correct height. So anyways guys, we are going to see you the next one, in which we are going to look into the rendering of skyboxes. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people.